Welcome. Automobile Engineering Today YouTube channel. Engine components and terms. The main problem in understanding the construction of the reciprocating piston engine is being able to identify and name the various parts making up the power unit. To this end, the following briefly describes the major components and the names given to them. Cylinder block. This is a cast structure with cylindrical holes bored to guide and support the pistons and to harness the working gases. It also provides a jacket to contain a liquid coolant. Cylinder head. This casting encloses the combustion end of the cylinder block and houses both the inlet and exhaust poppet valves and their ports to admit air-fuel mixture and to exhaust the combustion products. Crankcase. This is a cast rigid structure which supports and houses the crankshaft and bearings. It is usually cast as a mono construction with the cylinder block. Sump. This is a pressed steel or cast aluminium alloy container which encloses the bottom of the crankcase and provides a reservoir for the engine's lubricant. Piston. This is a pressure-tight cylindrical plunger which is subjected to the expanding gas pressure. Its function is to convert the gas pressure from combustion into a concentrated driving thrust along the connecting rod. It must therefore also act as a guide for the small end of the connecting rod. Piston rings. These are circular rings which seal the gaps made between the piston and the cylinder, their object being to prevent gas escaping and to control the amount of lubricant which is allowed to reach the top of the cylinder. Gudgeon pin. This pin transfers the thrust from the piston to the connecting rod's small end while permitting the rod to rock to and fro as the crankshaft rotates. Connecting rod. This acts as both a strut and a tie link rod. It transmits the linear pressure impulses acting on the piston to the crankshaft big end journal, where they are converted into turning effort. Crankshaft. A simple crankshaft consists of a circular section shaft which is bent or cranked to form two perpendicular crank arms in an offset big end journal. The unbent part of the shaft provides the main journals. The crankshaft is indirectly linked by the connecting rod to the piston. This enables the straight line motion of the piston to be transformed into a rotary motion at the crankshaft about the main journal axis. Crankshaft journals. These are highly finished cylindrical pins machined parallel on both the center axis and the offset axes of the crankshaft. When assembled, these journals rotate in plain bush-type bearings mounted in the crankcase, the main journals, and in one end of the connecting rod the big end journal. Small end. This refers to the hinged joint made by the gudgeon pin between the piston and the connecting rod so that the connecting rod is free to oscillate relative to the cylinder axis as it moves to and fro in the cylinder. Main ends. This refers to the rubbing pairs formed between the crankshaft main journals and their respective plain bearings mounted in the crankcase. Line of stroke. The center path the piston is forced to follow due to the constraints of the cylinder is known as the line of stroke. Inner and outer dead centers. When the crank arm and the connecting rod are aligned along the line of stroke, the piston will be in either one of its two extreme positions. If the piston is at its closest position to the cylinder head, the crank and piston are said to be at inner dead center (IDC) or top dead center (TDC). With the piston at its furthest position from the cylinder head, the crank and piston are said to be at outer dead center (ODC) or bottom dead center (BDC). These reference points are of considerable importance for valve to crankshaft timing and for either ignition or injection settings. Clearance volume. The space between the cylinder head and the piston crown at TDC is known as the clearance volume or the combustion chamber space. Crank throw. The distance from the center of the crankshaft main journal to the center of the big end journal is known as the crank throw. This radial length influences the leverage the gas pressure acting on the piston can apply in rotating the crankshaft. Piston stroke. The piston movement from IDC to ODC is known as the piston stroke and corresponds to the crankshaft rotating half a revolution of 180. It is also equal to twice the crank throw. L equals to R, where L equals piston stroke and R equals crank throw. Thus a long or short stroke will enable a large or small turning effort to be applied to the crankshaft respectively. Cylinder bore. The cylinder block is initially cast with sand cores occupying the cylinder spaces. After the sand cores have been removed, the rough holes are machined with a single point cutting tool attached radially at the end of a rotating bar. The removal of the unwanted metal in the hole is commonly known as boring the cylinder to size. Thus the finished cylindrical hole is known as the cylinder bore, and its internal diameter simply is the bore or bore size.